Welcome to the PetroSkills PetroAcademy module covering special purpose production logging at the fundamental competency level. This section provides an introduction to the module and explains the importance of the topic. This module will cover the following learning objectives: how noise and radioactive tracer logging tools work, how to use a noise log to distinguish between single-phase flow and two-phase flow, how to use noise and radioactive tracer log measurements to estimate flow rates, find leaks, and find fluid entry and exit points, know the benefits of a spectral noise log over a conventional noise log, how fiber optic temperature measurements are made and how to interpret them to find fluid entries and fluid exits, how to design an integrated production logging program to solve a basic production logging problem. Noise logging tools use a broadband acoustic source and 4 to 6 piezoelectric transducers in parallel as receivers. Conventional tools use 4 to 6 high-pass frequency filters to provide noise cuts at 200, 600, 1000, 2000, and sometimes 4000 and 6000 Hz. Spectral noise tools record full noise time series and convert to a power spectrum as a function of frequency. Why use noise logging tools? We can use them to locate fluid entry and exit points and leaks. We can sometimes estimate flow rates behind pipe. We can distinguish single-phase from two-phase flow. We can do range finding from blowout relief wells. Radioactive tracer tools use iodine 131 as a radioactive tracer. This tool ejects 5 cc of tracer per test. It uses 1 or 2 gamma ray detectors to measure the movement of the radioactive slug. For injection wells, drop down, log up through tracer, drop down again, log up again, and repeat until the tracer slug quits moving. Why use tracer tools? We can determine injection rates by zone in injection wells by determining the velocity of the movement of the radioactive slug. We can identify leaks behind pipe. We can measure flow rates in the 10 to 20 barrels per day rate that are below detectability of spinners and other logging tools. Fiber optic cables can be used to measure temperature along the length of the cable. The surface instrumentation uses a 1064 nanometer laser to emit 8 to 10 nanosecond pulses at 200 to 250 kilohertz. The time of the reflected pulse to reach the analyzer is used to determine depth. The ratio of the Raman anti-Stokes peak to Stokes peak is used to determine the temperature at depth. Measurements are stacked to improve precision and reported at 1 or 5 minute intervals. Why use fiber optic temperature? This instrumentation provides continuous temperature readout from installation over several years without need to intervene that one has to do with conventional logging tools. One can integrate changes in temperature with production data to identify intervals watering out or ceasing to produce. If you have a well that has a problem, you need to design a detailed logging program to acquire production logging data and/or other data to figure out what is wrong with the well. You cannot just tell the service company to go log such and such well. They need to know exactly what to do. Here is an approach that can be used to design an integrated production logging program for a problem well. Start by defining the problem to determine what is wrong. Set objectives to determine what you're going to try to do. Assemble critical background information so you know the conditions. Select logging tools, logging passes, logging conditions, and analysis methods based on critical information and the objectives. Justify the job, then document the program for the field operations group and the service company. Implement the program, analyze the data, and make recommendations. Why do I need to do this? You are in a much better position than the service company to know what is wrong with your well. You are more likely to select only logging tools needed to make the appropriate measurements and avoid running unnecessary tools. The service company has a vested interest in running more logging tools. You are more likely to actually collect the data to help you solve your problem than the service company. Without a good logging program, you are probably not going to get usable data.